Okay, so we have, I'm going to solve this one like I did the other ones previously. Um, I'm going to find, I have my common denominators here on the right side of the equation, and on the left, I have this 3. Okay, so on the right side, it's because these denominators are exactly the same, if I add them together, they should have the same denominator. Actually, let's do this off to the side so we can see what it looks like. K minus 1 on the bottom, and K minus 1 here and here. K minus 1. Across the numerator, we'll have K plus 3, and then K plus 3, and then a positive K. We'll combine our like terms, K and K. I'll have 2K plus 3, and our denominator is K minus 1. On the left side of the equation, we have a 3, which we can change into a fraction, is 3 over 1. And again, we can cross multiply and solve. So these two, K minus 1 times 3 is 3 times K minus 1, which is equal to 1 times 2K plus 3. We'll distribute and we'll solve for K. This side, distribute 3K minus 3, and I'll distribute and distribute 2K plus 3. Now, after distributing these two items, what you notice is we have a basic solving equations multi-step equation. So I'm going to move all the k's to one side. So I have a 2k here and a 3k here. I'm going to put them together. So minus 2k and minus 2k. Again, I like to move the smaller of the two items, so that way my numbers will stay positive, because 3 minus 2k is going to be just a positive k. And I'll bring this negative 3 down, equals positive 3, and I'll solve again. K should be by itself, plus 3 and plus 3. Final answer should be, these two go away, and I'll have K equals, should not have crossed this out, should be K equals 6. Okay. Now the difference between this one and the previous ones are, this one is, I solved the equation like I normally would, solving equations unit 2. Same thing with this one. The other items, the process is the same, but I was able to factor out and cancel whole entire binomials. Before this item, now I'm just canceling out single terms. So this is a little bit more common, something we're used to. The other one is a little bit different, where the factors are a little bit bigger instead of just single terms. Okay. Again, we can repeat the process. I'm going to do this one a little bit differently than the last, okay, to show you the different options you have. You don't have to do everything the same, but the idea is going to be consistent. My denominators are the ones that I'm mostly concerned about. I can move this one to the other side because these two are like terms. They can be added or subtracted together, the 2 and the 3. Or I can factor out this denominator here and rewrite this. They have a common factor of a b. And have a b times 2b minus 1. And make this one common so I can add them together. So that means this one would be requiring a 2b minus 1. Okay, so here I factored this out. I have a b and b minus 1, 2b minus 1. So in order to add up the right side together, I have to multiply by 1. That 1 is a version of 2b minus 1. So I multiply it here. Now our denominators will be exactly the same. So I'll distribute here and here, and I'll have 2b minus 1 over b, or 2b squared minus b, and I'll put this back together on the other side as well. 2b squared minus b, this is a plus, and my numerator is just this 2. On the left side, 3 over 2b squared minus b. Now, everything here, all my denominators, they're all exactly the same now. Okay, they're all exactly the same. What that means is I'm now only concerned with my numerator. I can get rid of every single denominator by multiplying it by this common denominator over 1. So I multiply here, these two will cancel. I'm going to multiply it again, this one times the 2, this one will cancel, and times the last one, this one will cancel and cancel. Should only be left with 3 equals 2 plus 2b minus 1. I'll combine my like terms, 2 minus 1, and I'll have 2b plus 1 equals 3. Again, now I'm going to solve for a single variable. This takes us back to unit 2 minus 1 minus 1. Inverse property, additive inverse, creates an identity, 2b equals 2. And then divide by 2, multiplicative inverse, creates an identity, divide by 2 on this side, and we'll get b equals 1. Okay. Here's your exit slip. I'll post it. I'll give you guys time at the end of class. Make sure that show your work and answer the questions. This should be 7F, sorry, 7F. Students solve rational expressions. Okay, independent work, everything on a separate piece of paper, practice together, and your word search, it is on the website. In case you forgot, I'm going to review it with you guys how to find it. Okay, show all your work on paper, please.